All right, in this video, I'm going to show you how to solve an equation when using a square root as an inverse operation. So typically, you're probably used to seeing two-step equations written out, but with a coefficient, a number in front of the variable here. But in this scenario, we have an exponent of 2. So how do we get rid of that exponent? Let me show you how. You're still going to draw that line down the middle of your equal sign, separating the left and the right side. We've got to isolate the variable of x, so that means we got to get x all alone. But because that exponent is attached to the x, that's going to be the last thing that we decide to get rid of. Instead, we're going to get rid of negative 150 first. How do I get rid of a negative 150? I do the opposite of that. Opposite of subtracting 150 would be to add 150. That's going to cancel it out and make a 0 right there. Now, if I take 150 and add that to the left side of this equation, I got to keep this equation balanced, so I'm going to add it to the right side as well. Adding 150 over here, so I have negative 29 plus 150, which is going to give me 121. That equal sign just stays right there on the line that we created, and x squared is going to be brought down because it's still there on the left side. Now what I have is x squared. So I have to use the opposite, the inverse operation of squaring a value, which would be square rooting that value. So you just draw a square root symbol around it, a radical, and I like to scratch the 2 and the root. Then I'm going to have to do the square root over here. The good news is 121 is a number that should be stuck in your brain somewhere as a perfect square root. It comes out nice and neat for us, so we're not going to have to deal with doing any simplifying of radicals. Square root of 121 is 11 or negative 11, so you're going to have 11 and negative 11 as results. That would work for this equation. Study hard and good luck on your upcoming test.